Hello friends, welcome to Study with Harshit. Today I am going to share with you complete revision of AI and ML in Business, Unit 1, Paper Code KMBN IT02, Artificial Intelligence. Artificial Intelligence AI is intelligence demonstrated by machine as opposed to natural intelligence displayed by animals including humans. Leading AI textbook define the field as the study of intelligent agents, any system that receive its environment and take action that maximize its chance of achieving its goal. Some popular accounts use the term artificial intelligence to describe machines that mimic cognitive function that humans associate with the human mind, such as learning and problem solving. However, this definition is rejected by major AI researchers. AI applications include advanced web search engine, example Google, recommendation system using by YouTube, Amazon and Netflix, understanding human speech such as Siri and Alexa, self-driving cars, example Tesla. As a scientific endeavor, machine learning grew out of the quest for artificial intelligence. In the early days of AI as an academic discipline, some researchers were interested in having machine learning from data. They attempted to approach the problem with various symbolic methods as well as what was then termed neural networks. Machine learning (ML), recognized as a separate field, started to flourish in the 1990s. The field changed its goal from achieving artificial intelligence to tackling solvable problems of a practical nature. It shifted focus away from the symbolic approaches it had inherited from AI and toward method and models borrowed from statistics and probability theory. The difference between ML and AI is frequently misunderstood. ML learns and predicts based on passive observation, whereas AI implies an agent interacting with the environment to learn and take that maximize its chance of successful achieving its goals. Goals of artificial intelligence: first, replicate human intelligence; second, solve knowledge intensive tasks; third, an intelligent connection of perception and action; fourth, building a machine which can perform tasks that requires human intelligence such as proving a theorem, playing chess, driving a car in traffic. Advantages of artificial intelligence AI: high speed. AI system can be of very high speed and fast decision making. Because of that, AI system can beat a chess champion in the chess game. High accuracy with less error. AI machine of system are prone to less error and high accuracy as its take decision as per pre-experience or information. High reliability. AI machines are highly reliable and can perform the same action multiple times with high accuracy. Digital assistance. AI can be very useful to provide digital assistance to the user, such as AI technology is currently used by various e-commerce websites to show the product as per customer requirement. Useful for risky area. AI machine can be useful in situations such as defusing a bomb, exploring the ocean flood, where to employ a human can be risky. Disadvantages of artificial intelligence: cannot think out of the box. Even we are making smarter machines with AI, but still they cannot work out of the box, as the robot will only do that work for which they are trained or programmed. High cost. The hardware and software requirement of AI is very costly as it requires lot of maintenance to meet current world requirement. No feelings and emotions. AI machine can be an outstanding performance, but still it does not have the feeling, so it cannot make any kind of emotional attachment with human and may sometimes be harmful. Data sources, primary and secondary source of data. To analyze, present and interpret information from the data, there has to be a process of gathering and sorting the data. There are different methods to gather data, all of which fall into two categories: primary data source and a secondary data source. The term primary data refers to the data originated by a researcher himself, while secondary data is the already existing data collected by agencies and organizations for the purpose of conducting an analysis. Primary data source can include survey, observation, questionnaires, experiment, personal interviews, and more. The data from ERP, enterprise resource planning, and CRM, customer relationship management systems, can also be used as a primary source of data. Secondary data source can be government publications, staging website, publications from independent research labs, journal articles, etc. The transformed raw data set into another format. In the process of data wrangling can also be seen as a secondary data source. Secondary data can be a key concept in terms of data enrichment, which the primary source data is not solid enough with information, and it can improve the precision of the analysis by adding more attribute and variables to the sample. Quantitative and qualitative data. Data can be defined by a set of variables with qualitative and quantitative nature. Qualitative data refers to the data that can provide insights and understanding about a particular problem. Quantitative data, as the name suggests, is one that deals with the quantity or number. This numerical data can be determined by categories or so called classes. Types of data sources: structured data, unstructured data, semi-structured data, historical and real-time data, internal and external data. Structured data is tabular data containing columns and rows which are very well defined. The main advantage of this type of data is being easily stored, entered, queried, modified, and analyzed. Structured data is often managed by structured query language or SQL, a programming language created for managing and querying data in relational management systems. Unstructured data is the rawest form of any data, and it can be in any type or file: pictures and graphic images, web pages, PDF files, videos, emails, word processing document, etc. This data is often stored in repositories of files. Extracting valuable information out of this type of data can be somewhat challenging. For example, a text can be analyzed by extracting the topic it covers and whether the text is positive or negative about them. Semi-structured data, as the name implies, semi-structured data is a cross between structured and unstructured data. A semi-structured data may have a consistent defined format. However, the structure may not be very strict. The structure may not be necessarily tabular, and part of the data may be in or contain defining types. In an example can be photo of other graphic tagged with keywords, making it easy to organize and locate graphics. Historical and real-time data. Historical dataset can help in answering exactly the types of questions that decision makers would like to benchmark against real-time data. Historical data sources can be best suited for building or modifying predictive models and offering insight that can improve long-term and strategic decision making. The basic definition of real-time data explains it as a data that is passed along the end user as quickly as it is gathered. Real-time data can be enormously valuable in things like traffic, GPS system, in benchmarking different kinds of analytics project and for keeping people informed through instant data delivery. In predictive analysis, both type of data source should be given equal consideration as both can help in predicting and identifying future trends. Internal and external data. Internal data is information gathered within an organization and can cover areas such as personal operations, finance, maintenance, procurement, and many more. Internal data can provide information on employee turnover, sales success, profit margin, structure, and dynamics of an organization. It is external data. External data is the information gathered from outside, including customer checking, website, and more. For example, external data gathered from social media can provide insights about the behavior, preferences, and motivation of customers. Knowledge acquisition process. First, data. The data indicates the fact about things. In other words, it describes things, for example, length 1.70 meter, weight 80 kg, 35-year-olds, and so on. This is data. Second, information. Data is a collection of individual facts without any relationship between them. Information refers to the process of extracting a relationship between a specific facts. When studying and analyzing data, describing the relationship between that data is information. For example, someone who is 1.70 meter tall would be 25, 35-year-old. Third, knowledge. As a result of the above, the organization obtains knowledge by linking information together and identifying recurring patterns. Knowledge acquisition process consists of 5 main steps. Data gathering. Data gathering is the first step in knowledge acquisition. First, you to determine what data will be collected, how and where this data is located. In other words, planning before anything else. Second, data organizing. In the previous step, the data state is often not well organized. Therefore, the knowledge management team must rearrange the data to obtain valuable information from it. This step. Third, summarize. In this step, various statistics are extracted from databases. These statistics are presented in tables and graphs in multiple forms. Fourth, analyzing. The information is analyzed looking for recurring patterns that can be considered a new characteristic or a new knowledge. Fifth, synthesizing. This step demands on joining statistics and patterns and coming out of them with fixed concept that can be ruled upon. These concepts are the knowledge you are looking for. Knowledge management stores these results and rules or laws in the organization's knowledge databases so that everyone who wants it can reach it. Knowledge representation. Knowledge representation and reasoning is the field of artificial intelligence AI dedicated to representing information about the world in a form that a computer system can use to solve complex tasks such as diagnosing a medical condition or having a dialogue in a natural language. Knowledge representation incorporates finding from psychology about how humans solve problems and represent knowledge in order to design formalism them will make complex systems easier to design and build. Knowledge representation and reasoning also incorporates finding from logic to automate various kinds of reasoning such as the application of rules or the relations of set and subsets. Following are the kind of knowledge which needs to be represented in AI system. Events. Events are the actions which occur in our world. Object. All the facts about object in our world domain. Example. Guitars contain strings. Trumpets are brass instruments. Performance. It describes behavior which involves knowledge about how to do things. Meta knowledge. It is knowledge about what we know. Facts. Facts are the trust about the real world and what we represent. Knowledge base. The central component of the knowledge based agent is the knowledge base. It is represented as a KB. Types of knowledge. First, declarative knowledge. Declarative knowledge is to know about something. It includes concepts, fact, and object. It is also called descriptive knowledge and expressed in declarative sentence. It is simpler than procedural language. Second, procedural knowledge. It is also known as imperative knowledge. Procedural knowledge is a type of knowledge which is responsible for knowing how to do something. It can be directly applied to any task. It includes rules, strategies, procedures, agenda. It is procedural knowledge depends on the task on which it can be applied. Third, meta knowledge. Knowledge about the other type of knowledge is called meta knowledge. Fourth, heuristic knowledge. Heuristic knowledge is representing knowledge about some expert in a field of subject. Heuristic knowledge is rule of thumb based on previous experience, awareness of approaches and which are good to work but not guarantee. Fifth, structural knowledge. Structural knowledge is basic knowledge to problem solving. It describes relationship between various concepts such as kind of part and grouping of something. It describes the relationship that exists between concepts and of object. Types of knowledge. There are numerous types of knowledge, but the most important distinction is between declarative and procedural knowledge. Declarative knowledge refers to the one memory for concepts, facts, or episodes, whereas procedural knowledge refers to the ability to perform various tasks. Knowledge of how to drive a car, solve a multiplication problem, or throw a football are all forms of procedural knowledge called procedure or productions. Characteristics of knowledge. Primitives. Semantic network where one of the first knowledge representation primitives, also data structure and algorithms for general fast search. In this area, there is a strong overlap with research in data structures and algorithms in computer science. In earlier systems, the Lisp programming language LISP, which was modeled after the lambda calculus, was often used as a form of functional knowledge representation, meta representation. This is also known as the issue of reflection in computer science. It refers to the capability of a formalized to have access to information about its own state. An example would be the meta sub-object protocol in Smalltalk and CLOS that gives developers runtime access to the class objects and enables them to dynamically redefine the structure of the knowledge base event at runtime. Incompleteness. Traditional logic requires additional axioms and constraints to deal with the real world as opposed to the world of mathematics. Also, it is often useful to associate degree of confidence with a statement, that is, not simply say Socrates is human, but rather Socrates is human with confidence 50%. This was one of the early innovations from expert system research which migrated to some commercial tools. The ability to associate certainty factors with rules and conclusions. Later research in this area is known as fuzzy logic. Definitions and universals versus fact and defaults. Universal are general statements about the world, such as all humans are mortal. Facts are a specific example of universal, such as a soldier is a human and therefore mortal. In logic term, definition and universal are about universal quantification, while facts and default are about existential quantification. Non-monotonic reasoning allows various kinds of hypothetical reasoning. The system associates facts asserted with the rules and facts used to justify them, and as those facts change updates the dependent knowledge as well. Expressive adequacy, the standard Bretchman and most AI researchers use to measure expressive adequacy is usually first order logic FOL. Theoretical limitations means that a full implementation of FOL is not practical. Researchers should be clear about how expressive they intended their representation to be. Reasoning efficiency. This reference to the runtime efficiency of the system, the ability of the system knowledge base to be updated, and the reasoners to develop new inferences in a reasonable period of time. In some way, this is the flip side of expressive adequacy. History of machine learning. Machine learning algorithms are used in a wide variety of applications, such as in medicine, email filtering, speech recognition, and computer vision, where it is difficult or unfeasible to develop conventional algorithm to perform the needed task. Machine learning ML is the study of computer algorithm that can improve automatically through experience and by the use of data. It is seen as a part of artificial intelligence. Machine learning algorithm build a model based on sample data known as training data in order to make prediction or decision without being explicitly programmed to do so. Data mining. Machine learning and data mining often employ the same method and overlap significant, but while machine learning focuses on prediction based on knowledge properties learned from the training data, data mining focuses on the discovering of previously known properties in the data. This is the analysis step of knowledge discovery in data. Data mining uses many machine learning methods but with different goals. In the other hand, machine learning also deploy data mining method as unsupervised learning or a pre-processing step to improve learner accuracy optimization. Machine learning also has intimate ties to optimization. Many learning problems are formulated as minimization of some loss function on a training set of examples. Loss function express the discrepancy between the prediction of the model being trained and the actual problem instance. Generalization. The difference between optimization and machine learning arises from the goal of generalization. While optimization algorithm can minimize the loss on a training set, machine learning is concerned with minimizing the loss of unseen samples. Characterizing the generalization of various learning algorithms is an active topic of current research, especially for deep learning algorithm approaches. Machine learning approaches are traditionally divided into three broad categories depending on the nature of the signal or feedback available to the learning system. Supervised learning. The computer is presented with example input and their desired output given by a teacher, and the goal is to learn a general rule that maps input to output. Unsupervised learning. No label are given to the learning algorithm, leaving it on its own find structure in its input. Unsupervised learning can be a goal in itself. Reinforcement learning. A computer program interacts with a dynamic environment in which the must perform a certain goal, such as driving a vehicle or playing a game against an opponent. As the native, its problem space, the program is a provided feedback that is analog to reward which it tries to maximize. Framework for building ML system, machine learning system. A machine learning framework is an interface that allow developers to build and deploy machine learning models faster and easier. A tool like this allow enterprises to scale their machine learning efforts securely while maintaining a healthy ML lifecycle. Features of machine learning framework. Machine learning framework allow enterprises to deploy, manage and scale their machine learning portfolio. Algorithm is the fastest route to deployment and make it easy to securely govern machine learning operations with a healthy machine learning lifecycle. With algorithm, you can connect your data and pre-trained models, deploy and serve edge APIs, manage your model and monitor performance, and secure your machine learning portfolio as it scales. Connectivity. A flexible machine learning framework connects to all necessary data sources in one secure central location for reusable, repeatable, and collaborative model management. Manage source code by pushing model into production directly from the code repository. Control data access by running model close to connectors and data sources for optimal security. Deploy models for whether they are with seamless infrastructure management. Deployment. Machine learning model only achieve value once they reaches production. Efficient model capabilities reduce the time it takes your organization to get a return on your machine learning investment. Deploy in any language and any format with flexible tooling capabilities. Serve models with a gift push to a highly scalable API in seconds. Various models automatically with a framework that compares and updates model while maintaining a dependable version for calls. Management. Split machine learning framework into reusable independent part and pipeline them together with a microservices architect. Operate your machine learning portfolio from one secure location to prevent work silos with a robust machine learning management system. Protect your model with access control. Use reporting allow you to gain full visibility into server use, model consumption and call detail to control costs. Scaling. Serverless scaling allow you to scale model on demand without latency concern, providing CPU and GPU support. Reduce data security vulnerability by access controlling your model management system. Govern models and test model performance for speed, accuracy and drift. Multi-cloud flexibility provides the options to deploy on algorithm or to keep models near data sources. KDD process. Data cleaning. Data cleaning is defined as removal of noisy and irrelevant data from collection. Cleaning is case of missing values. Cleaning noisy data where noise is a random or variance error. Cleaning with data discrepancy detection and data transformation tools. Data integration. Data integration is defined as heterogeneous data from multiple sources combined in a common source. Data integration using data migration. Data integration using data synchronization tools. Data integration using ETI, extract load transformation process. Data selection. Data selection is defined as the process where data relevant to the analysis is decided and retrieved from the data collection. Data selection by using neural network. Data selection using decision tree. Data selection using naive Bayes. Data selection using clustering, regression, etc. Data transformation. Data transformation is defined as the process of transforming data appropriate form required by mining procedure. Data transformation is a two-step process: data mining and code generation. Data mining, assigning elements from source base to destination to capture transformation. Code generation, creation of the actual transformation program. Data mining is defined as clever techniques that are applied to extract patterns potentially useful, transform tasks relevant data into patterns, decides purpose of model using classification or characterization. Pattern evaluation is defined as identifying strictly increasing patterns representing knowledge based on given measures. Find interesting core of each pattern, uses summarization and visualization to make data understandable by user. Knowledge representation is defined as technique which utilizes virtualization tools to represent data mining results, generate reports, generate tables, generate discriminant rules, classification rules, characterization rules, and etc. Artificial neural network, ANN. Artificial neural network, usually simply called neural networks, are computing systems inspired by the biological neural network that constitute animal brains. An ANN is based on a collection of connected units or nodes called artificial neuron, which loosely model the neuron in a biological brain. Each connection, like the synapses in a biological brain, can transmit a signal to other neurons. An artificial neuron receives a signal, then processes it, and can signal neuron connected to it. The signal at the connection is a real number, and the output of each neuron is computed by some non-linear function of the sum of its input. The connections are called edges. Neurons and edges typically have a weight that adjusts as learning procedure. Training. Neural networks learn by processing example, each of which contain a known input and result, forming probability weighted association between the two, which are stored within the data structure of the net itself. The training of a neural network from a given example is usually conducted by determining the difference between the processed output of the net and a target output. This difference is the error. Architecture of an artificial neural network. Artificial neural network primarily consists of three layers. Input layer. As the name suggests, it accepts input in several different formats provided by the second. Hidden layer. The hidden layer presents in between input and output layer. It performs all the calculations, find hidden patterns and features. And third one is output layer. The output goes through a series of transformations using the hidden layer, which finally results in output that is conveyed using this layer. The artificial neural network takes input and computes the weighted sum of the input and includes a bias. This computation is represented in the form of a transfer function. Advantages of artificial neural storing data on the entire net. Data that is used in traditional programming is stored on the whole net, not on a data. The disappearance of a couple of pieces of data in one place does not prevent the network from working. Parallel processing capability. Artificial neural networks have a numerical value that can perform more than one task simultaneously. Capability to work with incomplete knowledge. After ANN training, the information may produce output even with inadequate data. The loss of performance here relies upon the significance of missing data. Having fault tolerance. Extortion of one or more cells of ANN does not prevent it from generating output, and this feature makes the network fault tolerant. Having a memory distribution. For ANN is to be able to adapt. It is important to determine the example and to encourage the network according to the desired outcome by demonstrating these examples to the network. The succession of the network is directly proportional to the chosen instance, and if the event cannot appear to the network in all its aspects, it can produce false outcomes. Disadvantages of artificial neural network. Unrecognized behavior of the net. It is the most significant issue of ANN. When ANN produces a testing solution, it does not provide insight concerning why and how. It decreases trust in the net. Assurance of proper network structure. There is no particular guideline for determining the structure of artificial neural network. The appropriate network structure is accomplished through experience, trial and error. Hardware dependence. Artificial neural network need processors with parallel processing power as per their structure. Therefore, the realization of the equipment is dependent. The duration of the network is unknown. The network is reduced to a specific value of the error, and this value does not give us optimum result. Difficulty of showing the issue to the net. ANN can work with numerical data. Problems must be converted into numerical value before being introduced to ANN. The presentation mechanism to be resolved here will directly impact the performance of the network. It relies on the user's ability. Network design. Neural architecture search NAS uses machine learning to automate ANN design. Various approaches to NAS have designed network that compare well with hand designed systems. The basic search algorithm is to propose a candidate model, evaluate it against a dataset, and use the result as feedback to teach the NAS net. Design issues include decision, the number, types, and connectedness of network layers, as well as the size of each and the connection type. Hyperparameter must also be defined as part of the design. Governing matters such as how many neurons are in each layer, learning rate, depth, receptive field, and padding etc. Using artificial neural network requires an understanding of their characteristics. Choice of model. This depends on the data representation and the application. Overly complex model are slow learned. Learning algorithm. Numerous trade-offs exist between learning algorithms. Almost any algorithm will work well with the correct hyperparameter for training on the particular data set. However, selecting and training an algorithm for training on unseen data requires significant experimentation. Robustness. If the model, cost function, and learning algorithm are selected appropriately, the resulting ANN can become robust. ANN capabilities fall within the following broad categories: function appropriation or regression analysis, including time series, prediction, fitness, approximation, and model classification, including pattern and sequence recognition, detection, and sequential decision making. Data processing include filtering, clustering, blind source separation, and compression. Robotics, including directing manipulators and prostheses. Clustering, reinforcement learning. Clustering of data into groups is an important task to perform dimensionality reduction and to identify important properties of a dataset. A wide range of algorithms for clustering have been devised that all use some building in similarities distance measure that is built it into the algorithm to establish grouping of the data with a range of properties. These clustering algorithms group the data, attempting to maximize the distance between the cluster while minimizing the variance within the individual cluster. Clustering methods. Density-based method. These methods consider the clustering as the dense region having some similarities and difference from the lower dense region of the space. These methods have good accuracy and the ability to merge two clusters. Example: DBSCAN, density based spatial clustering of application with noise, and optics ordering points to identify clustering structure, etc. Hierarchical based methods. The clustering formed in this method form a tree type structure. Based on the hierarchy, new clustering are formed using the previous formed one. It is divided into two categories: bottom up approach and top down approach. Application of clustering in different fields. Marketing. It can be used to characterize and discover customer segments for marketing purpose. Biology. It can be used for classification among different species of plants and animals. Libraries. It is used to clustering different books on the basis of topic and information. Insurance. It is used to acknowledge the customer, their policy, and identify the fraud. City planning. It is used to make group of houses and to study their value based on their geographical locations and other factors present. Earthquake studies. By learning the earthquake affected area, we can determine the dangerous zone. Clustering algorithm. K means clustering algorithm. It is the simplest unsupervised learning algorithm that solve clustering problem. K means algorithm partitions an observation into K cluster where each observation belongs to the cluster with the nearest means served as prototype of the cluster. Here is the diagram. Decision tree learning. Decision tree learning or induction of decision tree is one of the predictive modeling approaches used in statistics, data mining and machine learning. It uses a decision tree to go from observations about an item to conclusion about the item's target value. Tree models where the target variable can take a discrete set of value are called classification tree. In this tree structure, leaves represent class, labels and branches represent conjunctions of features that lead to those class labels. Decision tree learning. Decision tree where the target variable can take continuous value are called regression tree. Decision tree are among the most popular machine learning algorithms given their intelligibility and simplicity. In data mining, decision tree can be described also as the combination of mathematical and computational tech to aid the description, categorization, and generalization of a given set of data. Decision tree terminology. Root node. Root node is from where the decision tree starts. It represents the entire dataset where further gets divided into two or more homogeneous sets. Here is the diagram also. I am describe all things in detail. Leaf node. Leaf node are the final output node and the tree cannot segregate it further after getting a leaf node. Splitting is the process of dividing the decision node and root node into subnode according to the given condition. Branch subtree, a tree formed by splitting the tree. Pruning is the process of removing the unwanted branches from the tree. Parent and child node. The root node of the tree is called the parent node and other nodes are called child node. Decision tree algorithm work in a decision tree for predicting the class of the given dataset. The algorithm starts from the root node of the tree. This algorithm compare the value of root attribute with the record real dataset attribute and based on the comparison follows the branch and jump into the next node. For the next node, the algorithm again compare the attribute value with the other subnode and move further. It continues the process until it reaches the leaf node of the tree. Decision tree working. Step 1. Begin the tree with the root node which contains the complete dataset. Step 2. Find the best attribute in the dataset using attribute selection measure. Third step. Divide the S into subset that contain possible value for the best attribute. Step 4. Generate the decision tree node which contains the best attribute. Step 5. Recursively make new decision tree using the subset of the dataset created in step 3. Continue this process until a stage of reach where you cannot further classify the node and call the final node as the leaf node. Bayesian networks. A Bayesian network, also known as Bayes network and Bayes net, belief network or decision net, is a probabilistic graphical model that represents a set of variables and their conditional dependencies via a directed acyclic graph. Bayesian networks are ideal for taking an event that occurred and predicting the likelihood that any one of the several possible known causes was the contributing factor. Bayesian networks. Designing a Bayesian network requires defining at least three things. Random variables. What are the random variables in the problem? Second, conditional relationship. What are the conditional relationships between the variables? Probability distribution. What are the probability distribution for each variable? Support vector machine. In machine learning, support vector machines are supervised learning model with associated learning algorithms that analyze data for classification and regression analysis developed at ET&T Bell Laboratories. Motivation. Classifying data is a common task in machine learning. Suppose some given data point each belong to one of two classes and the goal is to decide which class a new data point will be in. In the case of support vector machine, a data point is viewed as p-dimensional and we want to know whether we can separate such point with p-1 dimensional hyperplane. This is called linear classifier. Applications of support vector machine SVM can be used to solve various real-world problems. Classification of satellite data like SAR data using supervised SVM. Handwritten character can be recognized using SVM. The SVM algorithm has been widely applied in the biological and other sciences. Genetic algorithm. In computer science and operation research, a genetic algorithm GA is a meta heuristic inspired by the process of natural selection that belong to the larger class of evolutionary algorithm EA. Genetic algorithms are commonly used to generate high quality solutions to optimization and search problem by relying on biological inspired operations such as crossover and selection. Some example of GA application include optimizing decision tree for better performance, automatically solve Sudoku puzzles, hyperparameter optimization, etc. Issues in machine learning. The complexity of and quality trade-off. Building robust machine learning model requires substantial computational resources to process the features and labels. Coding a complex model requires significant effort from data scientists and software engineers. Complex model can require substantial computing power to execute and can take longer to derive a usable result. Poor quality of data. Data plays a significant role in the machine learning process. One of the significant issues that machine learning professionals face in the absence of good quality data. Unclear and noisy data can make the whole process extremely exhausting. We do not want to algorithm to make inaccurate and faulty predictions. Hence, the quality of data is essential to enhance the output. Overfitting of training data. Overfitting refers to a machine learning model trained with a massive amount of data that negatively affect its performance. It is like training to fit in oversized jeans. Unfortunately, this is one of the significant issues faced by machine learning professionals. Monitoring and maintenance. Creating a model is easy. Building a model can be automatic. However, maintenance and updating the model requires a plan and resource. Machine learning models are part of a long pipeline that starts with the features that are used to train the model. Slow implementation. This is one of the common issues faced by machine learning professionals. The machine learning models are highly efficient providing accurate result, but it takes a tremendous amount of time. Data science versus machine learning. It become very tough for industries for the storage of data until 2010. Now, when popular framework like Hadoop and other solved the problem of storage, the focus is on processing the data, and here data science and machine learning plays a big role. Data science and machine learning are closely related to each other but have different functionalities and different goals. At a glance, data science is a field to study the approaches to find insight from the raw data, where machine learning is the technique used by a group of data scientists to enable the machine to learn automatically from the past data. To understand the difference in depth, let us first have a brief introduction of two techniques. Machine learning used in data science. Modeling. The data modeling is a step where machine learning algorithms are used. So, this step includes the whole machine learning process. The machine learning process involved importing the data cleaning, building a model training, and model testing the model and improving the model's efficiency. Data exploration. It is a step where we understand the pattern of the data and try to find out the useful insight from the data. Deployment and optimization. This is the last step where the model is deployed on an actual project and the performance of the model is checked. Machine learning used in data science. Data acquisition. In this step, the data is required to solve the given problem for the recommendation system. We can get the rating provided by the user for different products and comments, purchase history, etc. Business requirement. In this step, we try to understand the requirement for the business problem for which we want to use it. Suppose we want to create a recommendation system and the business requires it to increase sales. Data processing. In this step, the raw data acquired from the previous is transformed into a suitable format so that it can be easily used by the further step. I hope you understand the whole Unit 1 revision. For more videos like this, please subscribe, study with Harshit. You can also follow us on Instagram and Facebook. Thank you so much for watching this video. Also, like this video. Thank you so much.